All right, everybody, welcome back. Today we're going to talk about your homework help video for your right triangle trig evaluating trig ratios worksheet. As always, I will go through and do the evens, and that will save the odds for you. So before I start, what I want to do is I just want to give myself a quick reminder of the trig ratios. So I'm going to have sine of theta, cosine of theta, tangent of theta. And I just want to think about what those relationships are so I can deal with secant, cosecant, and cotangent. So sine, of course, is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So sine goes with cosecant. So cosecant of theta would be equal to the hypotenuse over the opposite. Secant of theta would be equal to the hypotenuse over the adjacent. And last but not least, cotangent of theta would be equal to the adjacent over the opposite, right? So I'm going to be using those as I go. So in this situation, secant of theta right off the bat, theta is sitting right here as the angle, which makes 5 the opposite side. 13 is the hypotenuse because it's across from the right angle, and then 12 would be left to be the adjacent. So if I'm looking at secant, secant is the hypotenuse over the adjacent. So the hypotenuse in this situation is 13 over 12, and that would be my answer. Looking at problem number 4, cosecant of theta. Theta is sitting up here. This would be my hypotenuse across from the right angle. This would be the opposite across from the angle theta. And this would be my adjacent. Cosecant is the hypotenuse over the opposite. So in this situation, that would be 17 over 15, right? And I'm just going back to my little chart that I created up top as I move through these problems. Copy, I'm going to bring it with me. So for my next problem down here, we're being asked for secant of theta. So secant is the hypotenuse over the adjacent. So this is the hypotenuse because it's across from the right angle. Across from angle theta is always your opposite side, which means this is your adjacent side. So when I do secant, it's the hypotenuse over the adjacent. So this would be 21 over 14 square roots of 2. Now we do have some simplifying to do. We can make this into 3 over 2. And then we're going to have some rationalizing. So 3 over 2 square roots of 2, we'll multiply by the square root of 2 and the square root of 2. This will give us 3 square roots of 2 up top. And then on the bottom, I'm going to have square root of 2 times the square root of 2 will just be 2. So I will have 2 times 2, which is going to be, of course, 4. So 3 square roots of 2 over 4 will be my exact answer for that one. Looking at problem number 8, theta is sitting right here, which makes this the opposite, which makes this the adjacent, and which makes this the hypotenuse. Tangent is always the opposite over the adjacent, so I will have 22 over 2 square roots of 23. Let's simplify that right now. 2 goes into 22 11 times. 2 goes into 2 1 time. We do need to rationalize, so I'll have 11 over the square root of 23. So I'm going to multiply top and bottom by the square root of 23. On the bottom, that's going to turn this into just 23. And then up top, I'll have 11 square roots of 23 as my final answer. Looking ahead to problem number 10. Here is the angle we're given. So this is our opposite. This will be our hypotenuse. And this will be our adjacent. Now, coming over here to solve this problem, we are being asked to find cotangent of theta. Cotangent, let's go back to our list, is the adjacent over the opposite. So the adjacent side here is 2 square roots of 5, and the opposite is 4. So to reduce this, this would make this into 1 square root of 5 over 2, which would be our final answer. No need to rationalize since the square root is on the top. Looking at problem number 12, across from the right angle is always your hypotenuse. Across from our angle theta is our opposite, and that means this is our adjacent. We're being asked to find cotangent. Tangent is normally the opposite over the adjacent, so cotangent is going to be the adjacent over the opposite. So the adjacent is 12, the opposite is 24, and of course that can be reduced to be 1/2 as your final answer. Coming on down, I know number 13 is an odd problem, so it's technically yours, but I'll do half of it. So I will take care of how about I do this first part and then you'll do the second part. So coming over here to this one, we're being asked to find the sine of angle A, which is right here. So this will be our opposite side. This will be our hypotenuse because it's across from the right angle. And this will be our adjacent because it's what's left. For the sine, it is the opposite over the hypotenuse. So this will be 9 over 15, which reduces down to be 3 over 5. For the cosine, that would be the adjacent over the hypotenuse. So 12 over 15 is where that would start. 3 goes into 12 4 times, 3 goes into 15 5 times, so that would be 4/5 at the end of the day. Looking at the tangent, that's the opposite over the adjacent, so 9 over 12, which would end up being 3/4. Cosecant, as you remember, goes with sine. Secant goes with cosine, and cotangent goes with tangent. So when I come over here, I'm just going to take the flip of those values. So cosecant goes with sine. So when I come over here and I connect these two, sine was 3/5, so cosecant will be 5/3. Secant, or cosine was 4/5, so secant will be 5/4. And cotangent was tangent was 3/4, so cotangent will be 4/3. I hope you guys found this video helpful. If you have any questions, please make sure you're reaching out and asking. Thanks, guys. Have a great day. Okay, let's just escape that. My mouse is dying.